milling is analogous to something that GibbsCAM has had for a while, known as pinch turning. And with pinch turning, what you did was you had a lathe with two turrets, an upper and lower turret, and you are able to simultaneously turn from the top and the bottom. So in the same sort of way, we've now added double milling. So we can mill from the top with the tool in the top turret and from the bottom with the tool from the lower turret. So let's go on and see what this is all about. Let's start with the top. You'll notice that I have the YZ plane activated. Okay, so I'm going to be machining from the top. I'm going to use the tool in the top turret to create a pocket. So I'll use the standard roughing process. You'll notice that I put in good values for clearance planes, top of the cut, bottom of the cut. None of that's really different. We also want to make sure that we are specifying the correct machining coordinate system here, which we have. Once we have all that done, we go ahead and I'll use the profiler in this case to pick the geometry. One other thing I want to point out is that there are 3 of these rectangular pockets, so I did specify that I wanted it duplicated twice 120 degrees apart. So let's generate this process, and you can see that I have those there. Now in the same sort of way, I want to go ahead and use the lower turret tool. So I'll drag that tool down onto the same process. This time I'm going to be using the opposite coordinate system, the YZ negative one that's defined here. And again, make sure that I'm specifying that correctly here. Now I'm going to go ahead and pick the circular pocket geometry using the profiler as before, and let's go ahead and do that. Okay, so now I've got that duplicated in multiple places as well. Let's go into our machine sim, and I have a stop put in, so let's quickly go to the area where we could potentially have some problems. You'll notice that we are getting errors in the console that comes up. And what's happened is the circular pocket, the first one, is done. The top one is not. So if I step through at this point, we see the tool retract out of the circular pocket. And now it's going to just go ahead and index to the next circular pocket position and start that. Of course, the problem with that is when you do that, well, that's still machining up here, so the tool is going to go ahead and crash. This is obviously not an acceptable situation. So what do? Well, we have our sync control here. You'll notice that it is giving us some error messages. What we want to do is select the top portions of each one of these operations that I just created and put in what's known as a stroke sync. You'll notice that all the error messages go away here at this point. What it's telling it is that if one pocket finishes before the other, please wait until the other pocket is done before you go and index to the next position. Let's go back and see what happens now. I'm going to rewind my machine sim, go very quickly to the area where there's potentially a problem, and let's step through again. You'll notice now that it is holding on the bottom. As I step through here, the rectangular pocket finishes out. Let's slow this down a little bit and play it. And you will see the same sort of thing going on now for the other 2 positions. So that sync control removed that crashing error that we saw here before. By the way, other operations were done here for contouring to do the chamfering on the top and the bottom as we see here. But the same principle was applied with the sync control. Okay. So that's the end of this example. Let's go to another example that I have here. We're going to use a different process here in this example. We'll use polar and cylindrical milling just to demonstrate mainly that this sync control principle can be applied for different kinds of operations. Let's start out though by getting some geometry. We're going to do this slot here and the bottom slot here live for you so you see the entire process happen. So we need to get some geometry first. So let's go ahead and do that. I'm going to turn on my edge selection and pick some geometry here. And let's extract that geometry. All right, we have that all done. And I want this geometry to be relative to the YZ plane as the last example. And the YZ negative, we want some geometry that belongs to that as well. But let's start here on the top. So I'm going to pick this geometry. And I'm going to go ahead and say, let's unwrap this. Okay, so when you unwrap it, you are essentially flattening it out. I want to do one other thing with this geometry. I want to split this line right down the middle so I have a good start point for this geometry. And that's a standard plugin called GeoEdit Split. Split it right down the middle. And now the geometry looks good. I want to get the same geometry down here on the bottom. So a quick way to do that is with duplicate and mirror. Again, a standard function. And in the same sort of way, I want this now to belong to the bottom coordinate system. Great. So now we have our geometry all set for the top and the bottom for our polar and cylindrical milling. So I have two tools. As before, identical tools in the upper turret and the lower turret. Tool number 1, tool number 6. We're going to start with tool number 1. This time we are going to do a contour instead of a pocket. And again, you put in some good values for the upper and lower, or the both clearance planes and the top of the cut and the bottom of the cut as before. That's all standard stuff. Very important that we are machining from the correct coordinate system. So that's all set up. What we need to do now is pick our geometry. And again, I want to make sure we start right at that point. We are going to be doing a climb cut on this. And you can see that because we picked the polar and cylindrical milling option, it wraps it around that cylindrical shape according to the depth that we specified. In the same sort of way now, I want to do it from the bottom. So I'm going to activate that coordinate system. And we're going to use the bottom tool, tool number 6. I'll drag that onto the same process. These values should still be good relative to the bottom. Again, I do want to make sure though that I pick the correct coordinate system, and as before I have specified polar and cylindrical milling so that it will do that wrapping for me. And in the same sort of way, I'm going to now pick this bottom geometry, and I'm going to go in the a climb cut relative to the bottom as well, and select that. Looks good. Let's go into sync control. Sync control is telling us we have some problems. So we're going to do the same thing as before, put in a stroke sync. You'll notice that removes all the error messages. Now we want to do one other thing, which is we want to duplicate these toolpaths. You'll notice that we have similar slots on, in fact, identical slots on the top and the bottom in 2 more places. these are spaced 1 inch apart from each other. So I'm going to use a standard plugin called TP Trans to go ahead and duplicate that twice, -1 for the first set of ops, and again for the second set. Okay, let's go back into our sync control. More error messages, right? Because I have to put these syncs in now for these duplicated ones as well. Once I do that again, it removes all of the error messages. So we should be good there. Let's go into our machine sim and see what's going on. So now you see we are coming in from the top and the bottom simultaneously. Right. Let's go and step this back. Let's do the same thing as before. Let's add a little color to this so we can see that the first one will be, the one on top will be red, and the one on bottom will be kind of a fuchsia here. And let's run this. So it's looking good, all nice and synced up. I have a stop in there. So let's go beyond that. Now we see our duplicated toolpaths, which of course should run exactly the same since we put syncs in for them as well. And then there were some other ops made here for the other slots that are again symmetric about different planes. And as in the last example, we also do some chamfering on the inside and the outside. So obviously these are synced as before. And then we'll also see that we do some inside chamfering as well. So that's double milling, new in GibbsCAM 14, analogous to pinch turning that we've had for a while, very useful.